start. Maybe I can do
Yes.
it.
I did say start.
All right. Yeah, you did it. Nice.
Yeah. Hey everyone, this is Funny here. I am not a regular R user, or like I'm trying to get into the R world, learning how things can be done very easily using R as a programming language. So I started learning about the map functions when I'm trying to get the loops and all that stuff, reading through it. So today we'll be talking about how we can use I mean, the better ways of doing the loop functions, or because in R the loops considered to be little slower. So the learning objectives today are what are functionals. The We learn about the meanings and how it can be used and all that stuff, and the package per package, the how it is will be useful for us, the family of functionals, the map function and walk function with the per functions, and reduce and accumulate. And if time permits, we can talk about safely and possibly functions too, for the from per package. Okay. And so these are the like as indicated in the book, the chapters are 9.1 to 9.7. We may not be able to cover from 9.6 the predicates, and 9.7. So I mean, it's the time permits, and also there's too much of the theory behind it, which is I don't know, like I couldn't able to cover it up today. So the thing is, okay, now let's start with the prerequisites of what this function chapter is about. So to learn about the examples, and to understand the examples and how the map functions work, we need the basic function per package. And initially, mine when I was trying to say per PURR package, it was not getting resolved. So then, the mistake is it's PURRR. So I just wanted to make sure that whoever starts new, make sure that there is 3 R's, not 2 R's in there. Okay, so that's what my intention was, to mention it over there. And regarding the functionals, okay, we were talking about the functionals. What exactly is a functional? Functionals are functions that take a function as an input and return a vector as an output. Functionals that you probably have used before are apply, lapply, tapply, vapply. There are a lot of functions which are apply functions from base R. These are already functionals, and we'll see the differences between those and the map functions later on. And when I'm trying to show the differences and all that stuff. So, but functionals is something you in the previous chapters we learned about how to write individual functions, right? Now you get that function and try to apply that use that function to apply it over all the columns, so that you do not have to repeat it so many times. So okay, so that's the main intention of the functionals is. So a functional is a higher order function that takes a function as an argument. And basically the high level definition is that, and it is basically an alternative to loops. A function is better than for loop, which is better than while loop, and then repeat. So the books keeps on repeating it's that why it is better than the for loop and the while loop and all that stuff. So it says why it abstracts away the explicit for loop, making the code more concise and expressive. Yes, I agree with the author, because I started learning R with the never started with the base R. But when I started using the map, and but when I go back and try to use loop functions, it is little confusing, because and more coding, and you need to understand the loop concept and other stuff. So map functions is straightforward. It's like a ready-made bake a cake for us, a cake which is available to use. So it is much easier for starters or the people who are these functions makes the R more attractive for the new people or like me who's moving from different languages. Okay, the benefits is encourages the functions logic to be separated from iteration logic. Yes, I totally agree with this one, because in the loops you do not know where it starts, where it ends, but the map functions is there's a very clear distinction between what's happening and what it is doing it, and where what function is called and how it is called. And they can collapse into vectors and data frames easily, which is also kind of a neat helpful for me, the people who starting uh, or from the different languages and all that stuff. Now let's see the map function. The basic map function has two arguments, a vector and a function. It performs the function on each element of the vector and returns a list. So we can also pass in some additional argument into the function. So we'll see the additional argument and how it can be done. But in at very basic level, map always has two parameters or two things, two arguments, a vector which is what the values are, and a function the function that you want to do. So let's say, for example, that the simplest thing is a triple function. A triple is a function that takes the value of x and cubes it. Okay, it's as simple as that. So if the value of the x is 1 times 3 is going to be 1. So if it's going to be 2, it's going to be 2 cube, and it is 3, it is going to be 3 cube, as simple as that. So now if we run this part, so I can run this piece of code right here, and so the first one is 1. So if we check the value of it, it is going to be 1. So if I'm going to want to see the value of 2, if I do this one, it's going to be 6. It is 2 cube. And at the same time, I can also check the value of 3 here. So it's going to be 9. So as simple as that. So this is a triple function, and the function is called here, and the map, these are the values 1 2 3, and this is going to be changing here. So that's as simple as that. So as I said here, map 1 3 triple is equivalent of saying the list triple 1 triple 2 and triple 3, as simple as that. Okay, so this is a basic I mean, in basic level, that's exactly what map does, is takes a function, apply to each and every individual vector, and return the values. So that's in at base level, it is going to do that. So the next thing is graphically, if we want to understand the concept of map. In the book, the author really has pictures, speaks a lot of words, right? So this is the vector, this is the function that is going to be applied, and the result way is that the function is applied every single vector, and you get the values. So it takes the values, it returns a value. So we will discuss about that, but graphically, this is how we can analyze how the map does, what exactly map is. So behind the map actual code, if we see that map refers to an operation that associates each element of a given set with one or more elements of a second set. So this is in depth, what exactly it means. And if we look at the function code of what it does behind the screens, is it is actually a function by itself, and it takes a vector and a list basically here, and it applies the sequence along. This is the sequence along and all that stuff, and it sends out. So behind the screens, when you see what a function, the map function is, you can see this is the code that is it is as if it is generating like this one. So that's what simply does is nothing but it takes the values, does the function whatever values is, and returns it. So so map mask everything. The idea of if we go back here, the law, I don't know like how many of people have this issue, but initially whenever I started reading it, I used to figure out the list is always sideways, right? I mean, like instead of top to bottom. I mean, maybe like my language that where I used to work. I mean, like I always see the things top to bottom. I mean, like the rows, right, instead of having it a column. But the way that I was thinking of is right now is apply a function to each. The input, the picture that I visioned is input vector map is 1 2 3, then you add something here, so it would add +1 +2 and +3. So that's something, like it doesn't really matter, but this picture might be little different than that, but this is a picture that I after a little bit of research made my understanding much clearer. Okay, the list listing nothing but it adds each and everything. So and here, the explanation is that the functionality which is here is the R function that we wrote, and the left is what we have, and the right one is what we are going to get. So as simple as that. So the input list, the left box that is representing, if we go back here, the left box, and a collection of elements, each shape, of course, that's easy, but middle gate is a recipe and operation is the one which does that, and the output, which is on the right side, is a collection of results. Each result is applying the key that is map preserves the structure of the input, meaning that it takes three. This is something that I did not understand, but I have a question later on, and I just put it over there. But is the maps, he says that it takes so many of them, applies the functions and returns exactly the same amount of it. So these are the ones that I we need. I mean, we can discuss later on. So this is the one. So the benefits of using the map function in Perl function in the Perl languages, it is equivalent of lapply, the base lapply, returns a list and is the most general. And the author keeps on, I mean, like says why the list is much better on. I mean, he discussed at length. So it returns a list. The length of the input is equivalent to the length of the output. So this is something that I did not quite understand myself. I'm trying to see. The length of the input is basically, the length is nothing but the total number of observations, right? I mean, somebody can help me here. Because the length of the input is nothing but the total number of observations, and the length of the output is, say, for example, a mean of a certain rows or something. Then we would get the summary of it. So, or sum or mean of it. Would that the length is that he's talking about?
I think if you have I don't know, 10th length vector, you're going to get, and you use the mean function, you're going to have like for the output a mean of, oh no, if you have, I think I confused myself, but maybe it's better if I think like if you have an input that is a list with 10 vectors, and then you're going to have, and you use the mean function, then you're going to have an output that is a list with 10 means. I think that is a good example. I don't know if somebody can check that.
Yeah, so the length of 10 vectors, right? I mean, if you write a length of the 10 vectors, it would give you as 10 number, right?
Yeah,
And
yes,
that is a
exactly.
distinct count of it, right? Each counts like 10 of them. But the length of the output, say the output, I say I apply a mean of the map, mean of it. So this 10 would be having will be the list value, or the list length is going to be 1. So I'm not quite understood what does it mean, but he says that the length of the input is equivalent or equal to the length of the output. So I'm little confused over there, that statement. I was trying to understand. Maybe my knowledge is not that this thing, so maybe somebody else can pitch in to explain that concept.
Yeah, so he's talking about the length of the output is always supposed to be the same. So if you're using map as a function and you're passing it a list that has 10 items in it, right?
Hmm.
Or and then you should expect to get a list with 10 items as the output. And so if you were to use a function like mean, so if you were to have like a vector, a single vector of 10 numbers, and you want to apply the mean, if you were to do that with a map function, it would apply mean to each single element of that vector and give you a list with which I expect would be the same numbers back out as a list, right? So if your
Yeah.
numbers are 1, 2, 3, 4, it would say mean 1, and that would be the first element of the list. And then it would say mean 2, and that'd be the second element of the list. It wouldn't apply mean over that vector for you. But if you had a list that had vectors in it, so the first element of the list is a multi-number vector,
Okay.
then it would apply mean to that first element, and that would be your first element of your output list, and then it would go on to the next one. So does that
Oh,
clarify a little better?
yeah, now I get a picture of it. So basically, the vectors individually is a vector. So when we apply, okay, so the concept myself, I got confused. So individual vectors, when you apply it, it will give you the individual results out. It won't actually take care of everything together. But the way we apply is different. Okay, I mean, it takes some time to digest the list and all that stuff. But yes,
Sure.
I get the point of now. I mean, like I have to go back and play with it and all that stuff as you suggested. But let's see that. But this is what it says. So map is more flexible with additional arguments allowed. That's true. We'll see why. And map has a host of extensions. We'll see what it is going to be done on that stuff. Now the thing is, okay, now let's see what these different things are doing. So what are the different types of the variant atomic vectors now we have? Map character, map double, integer, and logical. We'll see in each example of how what it does and what it is. So let's start with simple example here. The run this thing here. The my function is triple. It just takes the values and triples it. So the first one is simple map. So if we do this one, it takes nothing but takes the values, and from 1 to 3 it just multiplies with 3 and it get actual values. There's nothing, it just do that. So double applies, like it sends the the thing I noticed is maybe that, like it is thing is like the way the double looks like is from a kind of a roll thing, and whereas a map it comes down as a column. I mean, just for visual appeal, but that is that there's this difference. That's what the author points out, that you cannot have sometimes you cannot apply the double function, but map does do that. So the way that I understood was it the way the shows and all that stuff. But anyway, that's a concept that we can read through it later on. But the logical is it shows whether it is true or false, and the way is it's like one na is na. No, this is the value here. There's no value here, so false, true, false. So something like that can be done, and in each individual ways, the output is pretty evident that it's a character. It would return the character values. If it is a logical value, it is going to return the true or false. So how, I mean, later on we can use it. So anonymous functions, okay, and shortcuts. So basically, we have seen this one. This is previously we saw this one where the data said that we are, I mean, the data frame that whatever we are using is empty cars, and the function that we are trying to do is a mean of what are the values that are here, and we are trying to get that the head of it. So if we run this piece of this thing, so it's going to give us the mean of the values of individual this thing. I know, sorry about that. So, yeah, by the way, the thing that I was talking about is we can, this is a WebR, is something that you must have already seen. I was little encouraged with using this in the slides so that whoever later on comes in, they can actually directly go this one, click on it and see what's happening instead of copying and pasting it in their this thing. I'm a little lazier, that's the only thing. So anyway, the run code is basically it takes the empty cars, the cylinders and all that stuff, and it gives us the mean of the each individual column. So can use .x. .x is something, the data set that we are using in reference to map.x and .f. .f is the name of the function. And the here we have seen this one, right? The function name f. So the shortcut that instead of writing the function x function, all those things, you can use, I don't know, like people say twiddle, but there are tilde, right? I mean, like people say tilde. I am used to saying tilde, but I really don't know that people call it twiddle. There's whatever you call it's a twiddle or tilde, whatever it is, but you can use that as a shortcut of saying function. And I'm not sure, I mean, the previous cohorts, they were having a discussion about why they called it a tilde or why any other thing, but I have no idea why they they use this sign as a function shortcut. But the if we see this one, it is a shortcut to a function that is being used. So here, if we see this one, the same thing as here, these two are exactly the same. Writing this function as f mean versus f dot f mean. Like the instead of writing all the function, you can just say tilde function x and or missing is equal to, or even simplified is that empty cars and just say mean. You do not have to even say a function, okay? And I'm not pretty sure whether it is okay with other functions, like they use it different functions, like say for example in the previous example triple, to directly call it as a triple here in the this thing, or it is only okay with the functions like mean or the functions which are already there, which we can use it over the base or all that stuff. So I haven't checked it out, but I was having this question about myself, because mean tilde mean is a function, right? I mean the mean is also a regular function. So I was not sure about that, but the simplicity of it is you can directly call it as a function and you can use it. And but the author says that it is a better, we he insists on writing the functions like this, where we know what is happening within the function, rather than calling it or shortcutting it as much as possible, because it adds to the confusion, or like adds to the person who is reading it rather than the author. Sometimes I see some functions a lot of times where the person who is really well versed it, he becomes lazy and writes it very short form, but it takes a lot of time for the other person to understand, okay, and think, okay, this is doing this way or that way. So there are a lot of different varieties of doing it. So I was just trying to play with, I mean, the previous cohort persons, people did play with it and how it can be done in a different ways. So that function is the x unique and length unique function. So first thing is that they define with x. X is the name of it, right? I mean, there's we'll see why it is called x and all that stuff. But x, or you can replace this x with a name of your own function. You can say unicorn, or you can say test, or you can say dist, whatever it is. You can replace that, and it would give the same amount, same results. So, and here see the length length of the function that we are trying to use it. So we can avoid the function altogether. We do not need that. If we call it as a tilde, right? The tilde would, and the remaining part of it exactly would give you the same result. But using the tilde, I mean, the author says that, using this function, you should always, make it as dot x rather than x. Like here, that's we can test it out, see if we can do this one. uh, I think, like the author points out that, we need to use compulsory dot x instead of x. There's going to be yeah, unexpected. Okay, I understand that. So this, I mean, I can test it out here. uh, of course, I don't know whether I can able to, people can see the my R Studio. uh, Anybody can confirm that they can see my R Studio, or should I do anything differently to check it
Yeah,
out?
we
So,
can see it, but maybe if you can zoom in a little bit.
oh yeah, in okay, yeah, yeah. Hopefully, I know I have two monitors, so something, these things makes it little. But anyway, this would give me the length of the unique observations. But if I take out the length and unique, okay, see this one. Yeah, I do have this example later on, but this one, does not really, the dot x does not work. It just returns the length of x. What exactly is x? X is, let's just a unique one, right? So just see, everything is 1 1 1 1 1. It doesn't really do anything, because there is a different, I mean, he will talk about the dot x and x. But if we do something like this one, it would only return the value or the length of the x instead of the entire thing. So that clarifies it. So the dot x, when you're using the tilde function, you have to use dot x and make sure that's what he says on. And there is also talk about dot one. Like there is this is something I learned as from yesterday. I mean, like preparing for this one, something that I learned is dot one. There's the way to shortcut to dot one, dot two, and dot three. Like you can actually use this one. So what it does is, an argument one is dot one is dot x. Instead of dot x, you can say dot one. And in the map to, or where you are using y, the y argument for it is dot two is y. And there is also, like he says, dot, instead of saying anything, to make sure that it is backward compatible. So if you see these dots here inside the function, it is nothing but lazy way of saying whatever it is, the functions, the values for it. Okay, so that is what I learned from talking about it. And he goes on, the double length. The length of the count is assigned as a row, so you can play, I mean, we can run it on around. But this one, it would give you error, like whatever this is going to be the length of unique. So unique has to be a function, and like something can be done. But the best way, he says, do not run this one as expected, because it might throw out an error without unique having a function. Like it's just unique number, right? The length is unique. So that's what the textbook says, is make sure that you use it right. So the syntax style for short, a good rule thumb is, okay, now what the author wants to talk about here is, say here, we were talking about this task and all that stuff, right? So this is something. So if we go in detail about the syntax style, the way of writing it, the author, basically the best practice. We do all languages to have best practices, right? Programming practices is to make sure you write the name of the function, and then you call it give it a name. Every function, give it a name, so that it's easier for us to understand what it does. What it does is like everybody wants to be called by a name. You don't want to give us an anonymous name. That's what my analogy is. It's better to give it a name so that you'll be happier and non-confusing and easy for the newcomers to understand and able to debug it. So it says style for short functions, like something like this, unique and all that stuff. So it's better to give it a name and all that stuff. So that's exactly he wants to say that, right? Now passing the arguments with dot dot dot. Okay, this is the base R extension where we have more arguments to pass on, and we need to understand that in a map function, when we have more arguments to pass on, it might not work. So he says in the example here, the library, this thing, he says the list of 1 to 5, and then there's another list, basically a list of 1 to 5, and there's list of 1 to A and NA. And when you want to we are trying to return a double map double and x mean of x, and so now when you run this piece of this thing, it would pass along a similar functions from variable. So we can do the same thing here. That's what he's saying is the mean of x, and we have to remember that it is coming from here and all that stuff. So it's exactly the same thing, like if you see this one, the entire piece of thing is this thing, like shortened form of it, but it's better to write it down that it is reading the data from here rather than ignoring it. That's what it says. So that suitable difference between placing an extra arguments inside the anonymous function compared with passing them to map. Putting them in an anonymous function means that they will be evaluated every time this function. Just putting them inside is making them that it is evaluated every time rather than putting it outside. So this piece of logic is really the easiest way to see it, right? I just wrote it down. So the easiest way to see is that if you have an additional argument random, the random function inside the double, meaning that this is the random function that we are going to apply for plus is my function. So here versus plus putting the random function inside the plus. Okay, so usually we have to get similar results because it's going to be, but if we see this one, they would be having two different kind of results. So placing the random results inside versus outside, it is different. And the reason for that is one reacts every time the function is going to be resolved. One resolves first and get the added out. So there are two different thoughts of it. Okay, so the way you put it out is little different. So make sure you have that thought about it. It's just putting it out there. Okay, so that's what the author talks about it. The argument names. Okay, now the recommended writing, as was talking about all the time, is recommended writing out of full names. Map, like say example is map. This one, he was talking about write exactly what it does, trim rather than. So it will, the way it does is the map x is nothing but mean of x of 1 or 1. So it releases basically reader remembering that the second argument is a mean function is a trim. Basically we need to remember that this last function, basically this function is that trimming it to 0.1. Okay, so the best the unnecessary confusion. So if I don't know what this piece of code is doing it, because if I see tomorrow, I'm not really sure, what does this 0.1 does? Is it point? I'll be wondering, right? Like something like that. So the best way he's saying is do it this way, like you add a simple word trim to 0.1 so that I can understand that the values of the mean are trimmed to 0.1 decimal. So 1 decimal would be displayed rather than making a wild guess. So he says that. So make sure it's better or a good programming practice to have all the arguments here. The reason why the arguments to map are little odd, instead of x and f here, right? He says they are dot x and dot f, right? So I was literally wondering, when I started learning about it, why did when he say dot x instead of saying x? That would be easier for us, right? So now he clearly says that per functions reduces the likelihood of such clash by using dot f and dot instead of more common f and x. So he went on to discuss about why and the x and f could be a problem rather than dot x and dot f. So, and it makes the life easier. And like sometimes if you have a variable x, he gives a very good example of the x and f could be having a problems rather than dot x and dot f. That's could be like that's a nice detailed explanation, which I couldn't put it here, but later on we can see that. Okay, so now we have a function called modify. Now the way this modify function works is for me is, say for example, I'm just looking at my perspective, like I have a function written and I wanted to see the results. So I would use that function, check the values, rather than I do not really want to disturb the original data set or a data frame. So the original data frame still looks exactly the same. I do not want to touch it, but I just want to see the results. So in that case, so say for example here, if you see this one, I've created a data frame which would have values 1, 2, 3, and y is 6, 5, 4. So this is what it is. It looks like that. Like I did not print it out, so I can just print out the original data frame. That would make the life easier. So if I see this one, 1, 2, 3, 6, 5, 4. So does that. Now I have, if I apply a map function to this thing, what happens is that this would actually change the x cube. I'm just doing x cube, right? It would do the 1 times 3, 2 times 3, and 3 times 3. So I would have that. If I do just a modify of it, just a modifier of the degrees of function, so I am not, it would still show me the results of what exactly it is doing it. I still see the results x3, 5. But if I say the df, whatever the df that I have initially started with is still the same. It is not actually changing the original data. So I hope it makes sense when you are trying not to change the original data, but still you want to see the results. Any questions on that? Hopefully, yeah. It's just a simple concept, but modify function does that. I haven't. We use it a lot, making sure that I see the data set. Usually outputting it to a new one, rather than this modify function is a lot of helpful. I can see the results rather than changing the original one. So the next topic that is the per style, that he says that the per style versus the base art style of using the map, what that is doing. So in this example, he was talking about the empty cars split. Basically he wants to split the empty cars as a cylinder, the cylinder type. So this, what it does is it splits the the data frame into the cylinders with 4, 6, and 8 cylinders respectively, and then you want to apply the linear model on each individual cylinders and get this thing. So step 1, we are going to have this. If we look at it, it's the map function here splits one at a time. Here the linear model is applied, then the coefficient of it, and the double is going to be the second coefficient of, so extract the coefficient. So each individual, I can clearly see what each line is doing it instead of doing it. So that's what he says the first style is. So end of the day, he's just I get the map double. So basically, this is the result that I'm going to get it, and the style is basically the declared style of doing it. So in declared way of, or the syntax, that's what. Now he compares it with how it can be done using the lapply function and the vapply function. Even though the results are exactly the same, it's just the comparison, how the base are versus the post style. Okay, so he gives us an example of like the same cylinder data set, that is the data frame that we got it from this one here, and we apply and all that stuff. So he does that. So he explains in detail of how we can do it and what could be the problems, like applying the function, then getting the data and all that stuff. It's a verbose, little bit of verbose. That's for, at least for me, to understand what it does each individual way. Then the most of the details are covered under the map function, so it's easier for the new people that coming in through, who are not well versed in the apply functions. So here the map variants is talking about, there are 23 primary variants of the map, but most of them fall under certain categories. So he says that this is the easiest way to understand is there are 5 different things. So list, so wherever, if there's like it's we are handling the lists, there's data, then the map 2, two arguments. The map versus map2 is that map takes one vector as an argument of this thing. Map2 has x and y, whereas map has x, and IMAP is more than 2. So he keeps on, he says that instead of having map2, map3, map4, depending upon the data, I mean the way that we can do it, it could be any number, right? More than 2, this is IMAP, and the P and IMAP and PM. And I really did not understand one argument plus index, but the examples we can talk about it. But the PMAP is also more than 2, the PMAP, and this is something very close to people who works on data frames, like the one in the real world, other than just vectors or lists and all that stuff. A PMAP is a helpful thing that actually I started trying to understand by using the PMAP first, and then went backwards. So my journey was a little bit different. So I was just looking for a solution where I found as a PMAP, and then said, what is this map doing it? Then trying to learn, came backwards and tried to learn, see all that stuff. So PMAP, logical, is atomic, and say the PWalk. We'll talk about the walking functions, walk, I walk, and all this. It looks fancier what is walk is doing it, but this is what the variants are. And these 23 variants are different types of it, but he mainly talks about this 5. So okay, I was trying to mention little time earlier, map versus map2, right? What does the map2 functions are? Map2 functionality is map function takes one x, and map it takes a simple function, takes x and squares it and does that. So it's just nothing. I already spoke about it, right? So it takes that. So now map2 is vectorized over 2 arguments, meaning both x and dot y are varied, or both given to a function dot f. And the simplest logic is the same thing. So if I want to have a function of x, value of x, rise it to the value of y. So simply the thing what I'm trying to do is I just want to rise the value of y. So here the explanation is one. It takes one at it. I mean, it maps 1 to 1 here, and just rises it. So value of y, the arguments take map2 are slightly different to the arguments of map. The two vectors come before the function rather than one. The basic implementation of map2 is simple, quite similar to map. Instead of iterating over one vector, we iterate over two vectors in parallel. So the map2 is very similar to what map does. So and it's very helpful when we are trying to have a combination of vectors. Like sometimes we need to act two times, two different things, like say writing out to external. We'll talk about it, right? But sometimes we do need to have two arguments for it. And the benefit of using map over apply functions, he goes on to talk about it, is this map function is basically written in language C language. So meaning that it is very resource oriented, and like it's very faster and much faster than the native functions or the pure functions, all that stuff. And it preserves the names of that, and we always know the return value type exactly. If it is a list, we'll get back the list, and that's what he meant to say, that we can apply the functions over multiple input values, as we saw, like so map2 versus the thing. So multiple input values, we can extend it. We can pass on additional arguments to the function, like missing. So this makes map function more flexible than apply. So it's easier to understand or easier to play around with, rather than apply function. We have to make sure a lot of restrictions, like say S apply or for apply V apply. That you have to. There are a lot of restrictions for that. At least when I was trying around, I always get kind of weird errors, or which is hard to debug. And for me, then the map function became my good friend. So now let's talk about walk and friends. So we use walk when we want to call a function for its side effects. So when I saw the side effects, I really thought, like from pharmaceutical background, I was thinking that, side effects is something, adverse events or something. No, side effects is something that what it does. What does, say for example, write CSV file, is it takes that file, whatever the file you have, and writes it out. There is an action done. So that's the reason why he says side effects of, right? Instead of, you do not want to capture that, you have to write it out. So that action. So what that's exactly he means is a side effects. If he's any doing action, then instead of using the map or map2 function, it is better to use write it. So like say for example, there are write CSV file or gg saving the plot. We want to use walk function other than the map. So say for example, here in the earlier example we saw this one, right? I'm just saying map concatenate and just say additional, and so that we can write it out. So if we see this one, the map, we have it does null attach. We see all these things because the cat itself does not anything. So it does all the extra things, additional things. These are all being populated here on top of the values that we have. Say 1, 2, 3. This is a list that we have, but to write it out, it just says all this one, right? Now, say here the map works in the sense that it generates a desired welcomes. It also returns a null value. Okay, so we if we do the same thing, similar thing, like the same thing with the walk function. Walk, where are you? So if we do the same thing, say per provides a walk family of functions that ignore the return values of function and instead returns .x invisibly. So this is what walk does. So walk is basically helps us to ignore it ignores the functionality, but it gives the results of it. So if we run this one, see this one, nice and neat. It gives us the values and ignores the values what it is doing here. I'm not quite sure why does that, why the map is designed that way, because maybe it was more of a debugging thing or that. But here he gives an example of cat function does not have a result. It usually return invisibly. That's what is an example he gives. So now when I do something like this cat hello, first one, if I do cat hello, it would give us this one. If I do the same thing as a function, just run this one, it gives a null value. Null value of just there's nothing here, that if I do this one, it's just a null value. But if I do the same thing with hello, it just appends to the hello, right? See, it appends the null value within after so it's kind of like I'm not sure why and where we use this concept of it, but I was just see that. I mean, he pointed it out, like using a walk function versus walk to, because the side effects to writing the disk. So this is a small thing that he keeps on talking about it. So one of the most useful walk versus walk to is basically is when you want to write it out to a disk, right? The one value is the actual destination route, that whether you want to write it down to a C folder, C drive or D drive, whatever the root of it. And then top of it you have another variable, another value, or the name of the file. So there are two different values. One could be a constant, another could be changing, right? So you need to capture those two and try to use it in the walk2. The walk2 will be much easier in those kind of scenarios where you're trying to write it down. So write it out, sorry, to just have a pair of values. So walk2, pwalk, or invisibly return the value of x, the first argument. This makes suitable for using in the middle of the pipeline. So I have to practice this one, but this is what he says, that using the walk is it's good when you're running it, when you're trying to do it within the deploy style, or within the pipelines. So note, I do not think so. This is what Hadley says. I have no idea. Maybe somebody can help me out here. That I do not think that it is .x or .1 that is written invisibly, but I'm not sure what it is. Hadley says that. Anyone, any idea like why or what it is exactly means that? Maybe is there anybody here? Okay.
Well, this could be design decision. Like, you want to maintain the length of the original arguments, and you want them to be non-missing if you have to use them anywhere later. So, since you explicitly say, well, I don't need the return values, that's why I'm using walk.
Okay.
It's better to return something rather than a null.
Null,
Typically,
yeah.
because if you put this into another string of pipes, then you don't want to find yourself iterating over 15 nulls rather than 15 actual values.
Yes, I get it now. Maybe I mean I have to keep practicing for that, but I see what your point is. So it's better to do that. So here the example of what I was talking is the pwalk would generate. I mean I can't generate here, but he captures this value as one string, and then the other string is like the PNG file attached to it. So it's this string, and then so it's better to use the pwalk this thing as the argument rather than doing it over this thing. So he gives us an example of instead of x. And one thing that he pointed out is for the pwalk and the pmap. He says explicitly that note that the name of the first argument for the p values, the p class or the P set of functions is, it is .l instead of .x. So we need to make note of it. Instead of x, it is .l. So this is a small difference that we have to keep in mind when you are trying to use the pwalk or pmap or those P set of functions. So that's what the IMAP is like. This is also very useful for the data frames and data sets, and when you're trying to do the for the application that I used, this one is I had a SAS data set where I have pushed it to like we created a JSON file, and from the JSON file I was trying to convert back to the RDS format or the data set for the R thing, and I had to map the labels from each one of them back to each, and that's when IMAP was very helpful. So the IMAP is like a map to, except that dot y is derived from the names of x or name sequence, sequence long. So if not, and these two produce the same result. IMAP is often that's what he clearly says, is often useful for constructing labels. So simple thing, the example is x is the empty cast, and the functionality is that the values of y as a mean. So for every individual label, basically he wants to have this label mean of for each individual variable. So it's a mean of the round. So when you do this something like this, so it does is mpg, the mpg has a mean of this value is dynamically captured here, and the mean of the miles per gallon. So if it is cylinder, it's automatically captured here, and the value of y, and it becomes this one. So it is, you do not have to do it line by line. I mean, it automatically does it for you. So that's easy. That makes the sometimes getting the labels and all that stuff very easy. So that's what he says here. Okay. So IMAP is often used to construct. So these functions are very helpful when you're trying to do or play with data frames, getting the labels and all that stuff. So any number of the PMAP, we have map as one argument dot x, map to is two argument dot x and dot y, and PMAP is many arguments. And the PMAP is you supply a single list. You can actually supply a list within this, and which contains any number of arguments. So that's the beauty of PMAP. The list of equal length vectors, something very similar to data frame. So yes, this is a thing that made me to move towards the PMAP. Is it works with literally great with data frame or in an equal number of lengths. So you can pass the name list or a data frame as an argument to a function. So this is very helpful for the people like who works on data frames and which has an equal list, equal length vectors. Now basically everything is back as a list, right, or a data vector within the R. So backwards, I started with the data frame programming and all that stuff. So that's when the PMAP and P functions I was able to use it. So that's the thing example that I wanted to share with you is convenient to call PMAP as a data frame. Sorry, it's not keeping what you call the time. So it's 1 o'clock, right? So what should we do now? Do you want to continue with the remaining or just stop it here? I have just few more slides to share with. Anyone?
I've got time if you want to finish up your slides.
Okay, sure. Thank you. So basically I was trying to talk about, I'll just move in faster. So this one is like, so the PMAP returns it falls in nice and neat with the data frames. The data frames, the PMAP is the one that can be used, and it takes more argument, more than map and map2. Okay, so this he keeps on explaining what are the differences between the base R and base this thing. And the reduce family, okay, this is something of very interesting. And the picture was very, I mean, like initially it was confusing for me, but when you actually take a look at it, it's upside down. Like that's what it took me a while to understand. It takes the value, the reduce is basically takes the value of the function, the result of it, and then applies it, and then takes a reduce. So it reduces, is basically goes on reducing it until the results are. So that's the way I understood. So it is very powerful when you're trying to do that. So simple example is that this is a very simple example. Say we on 1, 2, 3, 4, 5. I mean 1 plus 2 plus 3, 4, 5. So you, instead of writing all this, you can say just reduce of it and plus one argument addition, simple reduce, and that will give the same results and identical. It has an init value, initial value of it, and you can start with, and if you have a start value of something that is not the first argument of the vector, pass it on with the initial value. So it's self-explanatory, and you can do that, and it goes on. So you can change, but reduce does help the way of getting your programs. So the best example that we can see is the ggplot. The way the ggplot, we have three different things: g point, geom point, geom point. So the size of 8, 4, and 2 alpha values. The colors are different colors. So the easiest way is to reduce function. Reduce to function. The sizes are given this way. Alpha is same. The colors is going to be added to it, and the reduce function, right? So initialization, you just add the empty cast function right here. So the both of them is going to give you exactly the same result. So that's the best way of, the easiest way of applying for it is apply it in the ggplot, or the repetitive functions within a function. If you are repeating something within a function, so it's better to use the reduce. So this is a reduce style, how it does the full join and all stuff. So once you run it, it's self-explanatory on that. The accumulate function, okay, this is something that of my interest too. Is sometimes I wanted to see what individually happens, what exactly happens in the function you want to debug, or you want to see that. So better, I mean, the something is accumulate function. Accumulate function is nothing but it splits down it individually. It gives you the results, and along with it also gives intermediate steps, what's exactly happening. So the example here that I wanted to share is, say if I run accumulate function with the ggplot that we were talking about earlier, it would say first it does have nothing, next one it has printed yellow dots, then the red dots on top of it, and then the blue dots. So this is even though this is a final figure that we see, these are all intermediate things that it goes one at a time, right? It goes top on each other. So that we can see with accumulate function. So accumulative function is better useful or better suited when you want to debug something. So that's my understanding of that. So map reduce, he says this is a new technology, and Hadoop, big data, and all that stuff, they use that, and it's better to use that one. So plug function is to pay, it will single element of it, and will be very useful when you're trying to do the first element or something like that. But we can talk about, I mean, you can take a look at the plug function. I did not use it a lot, but each one is a string. So it is very helpful when you're trying to pick up, or the map individual values. The plug function can be used, and that would be very helpful. That's an example that he was talking about. There's a list, so within a list, right? So you can actually plug that values for it. So that's one thing. And the flatten, okay, flatten is a simple story. It actually flattens will return the list into a simple vector. When you are supplying the list, so it will return as a vector. So now this is something that's not I've seen in the book, but earlier Cohort people talked about it. Safely is an adverb function. So here it actually gives, if we see this one, right? This is the list 1 and 10, and A is the 1. So when you apply log for it as if the log function, what happens is that you get the values for those two, and log of A will give you an error, right? So that's simply, like the last value it throw out an error saying that, okay, this is something log, and character values, and you cannot apply log on character values. So it does that. And the possibly is something much safer, and it's simpler than safely, but you can actually give the output, output saying that what exactly you want to see the error, what kind of thing that you want to say. For example, you said possibly here, apply the same log function. If I do this one, see that I said NA, and it gives the values of 1 and 10, but for the A, it says not available or something like that. So you can give whatever error you want, and that pretty much covers. The other things that you want to talk about is how the mapper function and how the things are applied and so forth. But overall, this is what a map function or maps does that. I took more than 10 minutes to start for this, but this is very long, a very big chapter, and we left out some of them mostly from the, the author's point of view of applying map versus a list and all that stuff. I'm done talking. Any discussions, or we can leave?
I think I'm good. Thank you for the presentation. It was really I think there was some function that I didn't knew or know, and I'm going to start using it. For example, IMAP, I think is very elegant.
Yep.
Yeah.
that brought me here to the map functions. Yes.
Really? Yeah. Par is a really nice package. Well, thank you.
So if that's the case, we can say and.
Yeah, I think we have to say it in the chat.
Yes,
No?
that typing, yeah.